This is the third video for the final exam for Math 107. Here's a piecewise function, and the idea is to graph between x equal minus 13 and plus 13. However, it looks like there's not enough. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 13's out here somewhere where that little ditzel is, and it's over here. That's okay. Now, how do you do a piecewise function? A piecewise function, as you remember, has some sub-problems to them, each one based on a line in the definition of the function. So here's the first line. This says that y is 5 if f is less than 0. The next one says that y is 5 minus x, but only between 0 and 4. And the third one says that y is the log of x minus 3 for x greater than or equal to 4. You graph each separately, right? So the easiest thing to do is sort of, I'll just do this again. Mark off, this is the part of x for the first section. The next section, this is getting dangerous because there's a bug in the tool section here, and sometimes it knocks me off. Okay, between 0 and 4, okay. Oops. See that region right there, that green region? That didn't show up very well. There. That's where the second line, that's the area or the region of the graph where the second line is graphed. So we're all color coordinated here. And now the next one is all the way out to here. I think you can divide that up. You should be pretty good on that. Now let's go back and see what we can do here. For x less than 0, for the first piece here, this piecewise function, y is 5. Okay, here's 5 right here. Oh, this was supposed to be yellow. I didn't change it. Yellow. Okay, so here's the function. It's just a constant 5, so all you have to do is draw a straight line. That's all somebody has to do. Obviously, I can't. Okay, good enough. There's your yellow line. All right. It's the end of the semester, so we'll just let it be. Okay, now this is a little more interesting. Let's go to green here. For the next one, there's an x. How do you handle it when there's an x? You evaluate this function at the endpoints of the domain. So you're going to evaluate it at x equals 0 and x equals 4. And that's going to give me 2 points. Obviously, this is a linear function because x is raised to the first power only. So with those 2 points, I can draw the line. All right, so here we go. So at first, it's 5 minus 0 because I evaluated 0, and that's 5. Okay, so the first point is right here. When x is 0, it has a value of 5. At the other end point, it's 4. 5 minus 4 is 1, so it has a value 1. That's it. I'm done. Now let's see if we can draw some kind of straight line there. It was supposed to be a green straight line, but there you go. Now, look at the next line. It's a logarithmic function, and you need to graph between 4 and 13. Oh, it's actually an open circle here, isn't it? Because this is less than. All right. So don't be too lost right away. Instead, evaluate the function at the endpoint. So I'm going to evaluate it at 4. This is a setup, so it's not too bad. 4 minus 3. Okay, so that's the log of 1. The log of 1 is always 0. So here you go. There's a jump in this one. Now look at the other endpoint. It was 13. The log of 13 minus 3 is the log of 10. What's the log of 10? It's 1. Okay. So way over here, it's going to be 1, and so the function looks like that. First piece right here at that terrifically silly looking line here, and this piece down here, and there is a jump. Okay. For these problems, you're given a function f of x equals the absolute value of x, and you have to write the equation and draw the graph for reflecting the function about the x-axis. Right? Then you sketch and graph the function, and then you're given another one. And so I'm going to do that on the next page. Maybe. All right, here we go. Okay, in the first case, the function was the absolute value of x. And I'm going to draw this in, but it's not going to count. What does the absolute value of x looks like? That's the function that looks like the letter v, because when x is 0, it's 0. When x is 1, it's 1. When x is 2, it's 2. When x is 3, it's 3, etc. So maybe I'll even do the straight line bit. Okay, so it's just a straight line like this. Okay. On the other side, when x is 1, negative 1, the absolute value is 1. When x is minus 2, the absolute value is 2. When x is negative 3, the absolute value is 3. So on this side, there you go. Well, yeah. That is f of x. Now if you want to reflect it about the x-axis, that means what is positive becomes negative, what is negative becomes positive. To write that equation, the new function, g of x, is minus the absolute value of x. Here's the function. How would it look? It looks like this. Okay. So this is a reflection about the x-axis. Here was the original function right here. And this is your x-axis. Right. And here's the y-axis up here. Okay. Now, for this problem, for this function, we again have the absolute value of x. But now, instead of plotting a bunch of points, you should use reasoning. If you take the x and subtract a number from it, that translates the graph. Translate means to move without changing the shape. You translate the graph 3 units to the right. If it was a plus 3, you translate 3 to the left. Right? So that's the first thing you know about this. You know that this peak here, if the 2 wasn't there, this peak here would just move over to 3. But now the plus 2 on the edge means translate it vertically up 2. So over 3, up 2, and now your graph just comes in from there. Okay, so here you go. And so this distance is the 2, which came from here. The fact that it moved 3 in this direction came from there. And that's it.